Hello friends, welcome once again to my next video tutorial on Java for beginners. In this video, we are going to discuss about the types of polymorphism in Java. We have already discussed about polymorphism in my previous video. Now it's time to go in more details into polymorphism. So there are two types of polymorphism in Java. First one is runtime polymorphism that we can call as dynamic polymorphism also. And second one is compile time polymorphism that also we can call static polymorphism. Okay. First, we will discuss about runtime polymorphism. So what is runtime polymorphism? Runtime polymorphism is a process that we can achieve at runtime rather than compile time. Okay, so there are two ways to achieve runtime polymorphism in Java. First way is we can achieve through method overloading using instance methods, and second way to achieve runtime polymorphism is method overriding using instance methods. Okay, so to understand in more detail, let's take an example. So in this example, we have demo class, which is my base class. Okay, and this class contains two methods with the same name, but number of parameters are different. Okay, so I have defined both the method name result. First method is having two parameters, integer a and integer b, and this method will display the addition of two integer values which we have passed, that is a and b. So it will display the result of a plus b, right? Similarly, second method is having three parameters, integer a, integer b and integer c, and this method display the addition of three integer type values, a plus b plus c. So our first method is displaying the addition of two integer, and this second method is displaying the addition of three integers. Okay, so this is the difference in both the methods. And after that, I have defined one more class called sample class, which is derived from demo class, our base class, right? So child class contains a method called result having two parameters, which is same as base class, right? So if we say this method, everything is same as base class method, same name, same number of parameters, but here logic is different. Method in child class, which is going to display the multiplication of two integer values a into b. So please look carefully, this method is doing multiplication, not addition. Okay, so now we have a base class and child class. In base class, I have two methods with the same name but different number of parameters. One is having two parameters, another method is having three parameters. Okay, and in child class, I have one method which is same as base class method, which is having same name and same number of parameters, but we have different logic. Okay, now we will go to our main method, and here we will define the reference of our demo class. So we will just define demo d1 is equal to new demo, and with the help of reference d1 we are going to call result methods. So here d1 dot result, and I am passing two values, and another one is d1 dot result, but here I am passing three values. So in this method I am passing the two values 10 and 20, and in this method I am passing the three values 10, 20 and 30. Okay, after that we will define one more reference of our demo class. So we will just define demo d2 is equal to new sample. So this time the reference d2 of demo class is pointing to the object of sample class, which is a child class. So reference d1 is pointing to the demo class, but reference d2 is pointing to the sample class, which is a child class, right? Then with the help of this reference d2, we are calling result method again with two parameters, and here I am passing two values 10 and 20. Okay, so this is our program. If we run and compile this program, the output is this. Now I have two questions. My first question is, this is all done by Java compiler or JVM? And my second question, who will decide which method is executed in out of these three methods? Any idea? Okay, I will tell. If we see here, we called result method with the help of d1, and d1 is pointing to the demo class, our base class. So that is confirmed, methods are called from the base class, not from the child class, because reference variable d1 is pointing to the base class object. It means Java compiler cannot decide at the time of compilation which method is actually called. It has to wait till the object is created, and creation of object take place at runtime by JVM. So here I can say JVM will decide which method is actually called at runtime, and we are calling methods from the base class. So here you got the answer of our first question, right? JVM only will decide which method is actually called at the runtime. Okay, now go to the my next question. So that is confirmed, result method is going to be called from the base class. But here we have two result methods. One is having two parameters and another one is having three parameters. Okay, so first we'll go to the this statement, and this result method from the base class, which is having two parameters, are called by this statement. Why? Because both are having two parameters, and this method will display the result of addition of two numbers is 30. 10 plus 20 is 30. Okay, and this result method, which is having three parameters, are called by this statement. Why? Because both are having three parameters, and this method will display the result of addition of three numbers is 60. 10 plus 20 plus 30, which is 60. So if you notice here, these two parameters JVM is deciding based on the method signature. So this is called as method overloading. Here you got the answer of our second question. They are calling the methods based on the method signature, right? So if we see, JVM knows and binds the method call with the correct method based on the signature at the time of running the program. So we can say this is the perfect example of dynamic polymorphism, method overloading using instance methods. Okay, now go to the next one. As we know that method in superclass and subclass have same name and same parameters, means this time the method signature is also same. Then how JVM decide which method needs to be called? So JVM call the method depending on the class name of the object which is used to call the method. So this time the reference D2 of demo class is pointing to the object of the sample class, which is a child class, right? So here we are calling the result method by using reference D2, which is pointing to subclass object. So subclass method is only executed by the JVM. So the result method from the child class are called and executed by this statement, and it will display the result of multiplication of two numbers is 200. 10 into 20, which is 200, right? So this is called as method overriding. So this is the perfect example of method overriding using instance methods. So we can achieve runtime polymorphism with the help of method overloading using instance methods and method overriding using instance methods. So here the parent class reference can hold object of parent class or any subclass of parent, right? Next, let's discuss about compile time polymorphism. What is compile time polymorphism? Compile time polymorphism is a process that we can achieve at compile time. Or in other words, Java compiler knows which method is called at the time of compilation. Of course, JVM also execute the method later, but compiler knows and can bind the method call with method code at the time of compilation. So static polymorphism can be achieved by static methods, private methods, and final method. The reason is that all these three methods, static method, private method, and final method, maintain only one copy in memory that is available to all the objects of the class. So Java compiler knows which method is called at the time of compilation, or I can say in other words, there is no need to wait till objects are created. So at the time of compilation, the method call can be bound with actual method body. So this comes under static polymorphism. Understood? So I hope you enjoyed this video. Please like, share and subscribe this video. Thank you.